Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. The number of burglaries occurring on Burlington Street during a one-year period is Poisson distributed with mean 1. Calculate the expected number of burglaries on Burlington Street in a one-year period given that there are at least 2 burglaries. And here's the solution. Let us write n for the random number of burglaries occurring on Burlington Street during a one-year period. So we know that n has a Poisson distribution with mean 1. We are looking for the expected value of n given that n is greater than or equal to 2. We have for n equal to 2, 3, and so on. These are the only possible values of n because it's conditional on n being greater than or equal to 2. And of course n is a discrete random variable whose possible values, the underlying Poisson, is discrete, and its possible values are 0, 1, 2, 3, and so on. But we have a distribution that's conditional on n greater than or equal to 2, and therefore the only possible values are 2, 3, 4, and so on, positive integers starting with 2 all the way to infinity. So the probability that n is equal to n, given that n is greater than or equal to 2, is the probability of the intersection of the two events, and that's just the probability that n is equal to lowercase n, because that event is a subset of the event that n is greater than or equal to 2, for n being one of the values that are possible, divided by the probability that n is greater than or equal to 2. That's the probability that n is equal to n, divided by 1 minus the probability that n is 0, minus the probability that n is 1. Because probability that n is greater than or equal to 2 is equal to 1 minus the probability that n is less than 2. And less than 2 for this discrete random variable means 0 or 1. And then the top is equal to 1 to the nth times e to the minus 1 over n factorial. That's the straightforward formula for the probability function of the Poisson distribution with mean 1. And the bottom is 1 minus 1 to the 0 times e to the minus 1 over 0 factorial minus 1 to the first times e to the minus 1 over 1 factorial. And now we multiply the top and the bottom by e. So e times e to the minus 1 makes it 1, and 1 to the nth is 1, and the top becomes 1 over n factorial. And at the bottom we have e times 1 is e. E times e to the negative 1 is 1, so the second expression becomes 1 times 1 over 1, and that's 1. And the third expression also becomes 1 times 1 over 1. So we get 1 over n factorial divided by e minus 1, and that's 1 over e minus 2 times n factorial. And that's the probability function of this conditional random variable. And then the expected value of n is equal to the sum from n equal to 2 to plus infinity of n over e to the minus 2 times n factorial, which is 1 over e to the minus 2 times the sum from n equal to 2 to plus infinity of 1 over n minus 1 factorial, because n factorial divided by n is equal to n minus 1 factorial, and that's equal to the sum for 1 over e to the minus 2 times the sum from k equal to 1 to plus infinity of 1 over k factorial if we replace n minus 1 by k, a new variable there. And of course, n minus 1 for n equal to 2 is equal to 1, so k starts from 1 and runs all the way to infinity. Now, if we add the term for k equal to 0 to this sum. That term is 1 over 0 factorial, so it's 1. So if we start this series from 0, then we need to subtract 1 to make up for the fact that we added 1. But then this becomes 1 over e to the minus 2 times the sum from k equal to 0 to plus infinity of 1 over k factorial minus 1. And of course that sum is just e to the first, because this is the power series expansion of the exponential function. So this becomes 1 over e to the minus 2 times e to the first minus 1. And the whole thing is equal to e to the minus 1 over e to the minus 2. I'm sorry, e minus 1 over e minus 2, not e to the power. So e minus 1 over e minus 2. And that's equal to approximately 2.39221191. That's answer B. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.